Welcome back. Excuse me. This video is going to walk through the calculations associated with the experimental procedure that you just watched, or perhaps the experimental procedure that you just finished. In any event, I'm going to use the data that I obtained from my experiment or the demonstration of the experiment. You will, of course, use your data, which is going to look similar. If your data is different, don't worry about that. Do not presume that my data is quote unquote the correct data. The correct data and calculations are the data and calculations that you obtained. So without further ado, I'm just going to jump right into the calculations again using my data. So here we go. The mass of potassium, aluminum sulfate with some unknown molecules of water, plus what I'm simply going to call the aluminum container, equaled 7.23 grams. The mass of just the aluminum container was equal to 5.21 grams. So I'm purposely setting these up to look rather like linear equations, so that when I subtract the two from each other, this term remains. So I get the mass of potassium, aluminum sulfate hydrate, excuse me, 2.02 grams. Okay. Now I'm going to determine the masses of each of the individual components. In other words, I want the mass of the potassium aluminum sulfate, and I want the mass of the water. So the first one, and in no particular order, the mass of the potassium aluminum sulfate plus, again, I'm going to call it just AL container for aluminum container, equals 7.23 grams. After the third heating, which for me is the last heating, for you, it might be your second heating. It might be your fourth heating. I don't know. It is the mass after your last heating. Pardon me, I see I need to correct something up here. Let me come right up there and put XH2O. And that equaled, or this equals 6.10 grams. So here's the mass that I started with. Here's the mass that I ended with. It should be evident that the difference between those two is the mass of the water. And you can see I've got it up here, but nowhere else. So I'm just going to keep my methodology the same. The water is the difference in those two values, or 1.13 grams. Before I scroll off, so the mass of the entire substance, 2.02 grams. The mass of just the water is 1.13 grams. So again, a couple of different ways to do it, but I'll do it this way. The mass of the potassium, aluminum sulfate hydrate, the alum, 2.02 grams. The mass of the, the mass of just the water, what did we say it was? 1.13 grams. Excuse me, I want to check something real quick. Yeah, we're good. So if I subtract these from one another, it is the mass of the potassium aluminum sulfate equals 0.89 grams, because the water cancels it out in this algebraic representation. So I now have mass of water, mass of potassium aluminum sulfate. So at this point, this should look a lot like the empirical formula calculations you've done for combustion analysis. And I want to convert the masses to moles. So I have 1.13 grams H2O, 1 mole H2O, 18.02 grams, and that equals, get my calculator out, I get a value of 0.0627 moles of water. I have 0.89 grams potassium aluminum sulfate times 1 mole is, I have this calculated, 258.21 grams. And of course, right here, I should have put potassium aluminum sulfate, but I think that's pretty clear. Let's see what value I get. I get 0.00345 moles of potassium aluminum. Sorry, I'm going to squeeze this in. So that gives me the number of moles in my original 2.02 gram sample. Pardon me while I write something down real quick. Okay, let me scroll down. Oops, looks like I'm at the bottom of the page. I'll find another page here in a moment. There we go. Let's go all the way to the top. There we go. So I have potassium, aluminum, sulfate, 2. Put some square brackets. Oops, my pen is creating problems again. I wish I could figure out what I happen to be touching that does that to me. I don't know, so I'm just going to start again down here. Maybe if I choose a different color. Well, you'll excuse me, I am not certain what is occurring here to create this problem. Well, bear with me for a moment. Okay, let's start again. I have potassium, aluminum, sulfate, 2, put square brackets around all of that. And I believe the value that I had was 0.00345. And I'll go ahead and use square brackets. H2O, and the value was 0.0627. 0.00345, 0.00345. Obviously, the first term is just 1, which was what we were looking for. And I have, let me do that division here. Now, unlike exam questions and homework problems where these ratios turn into numbers almost exactly equal to whole numbers, when you have actual experimental data, there's going to be deviation. So I get 18.17, and we have to interpret that. In this case, it's pretty clear that the value that I should use is 18. So using my data, the empirical formula is determined to be potassium aluminum sulfate dot 18 waters. That ends our discussion. We'll be talking in class.